Imagine, if you will, a star so ancient that its very existence threatens to unravel the story of our universe. Nestled in the constellation Libra, 190 light-years from Earth, HD 140283, better known as the Methuselah Star, is a celestial enigma. At first glance, it's unremarkable. No dazzling brightness, no monstrous size. But in the early 2000s, this star sparked a scientific crisis. Astronomers calculated its age to be 16 billion years. There's just one problem. The universe itself is only 13.8 billion years old. How could a star predate the cosmos? In the 1950s, spectroscopic analysis revealed HD 140283's secret. It contains mere 0.4% of the sun's iron content. Heavy elements like iron are forged in stellar furnaces and supernovae, so this scarcity hinted at primordial origins. But when 21st century astronomers plugged its data into stellar models, the age they derived was unthinkable, 2 billion years older than the universe. The implications: either our cosmic timeline was wrong, or our understanding of stars was fatally flawed. The Methuselah Star didn't just challenge textbooks, it threw cosmology into chaos. If true, it undermined the Big Bang, the cornerstone of modern cosmology. Headlines screamed, "Star older than universe found." Scientists split into camps. Some questioned the Big Bang, others doubled down, insisting we'd miscalculated the star's age. But how? To grasp this paradox, we must rewind to the universe's infancy. After the Big Bang, the cosmos was a seething plasma of particles. After 380,000 years, atoms formed, hydrogen and helium, the universe's first elements. Then, 150 million years later, gravity sculpted these gases into the first stars, population the third. These behemoths, hundreds of times the sun's mass, burned hot and died young, seeding the cosmos with heavy elements in their explosive deaths. Population the 3 stars birthed population 2 stars, like Methuselah, which inherited trace metals. Younger stars, like our Sun, population Raman, are metal-rich. Methuselah's composition, nearly pristine hydrogen and helium, marks it as a relic of the second generation. But if it's a population 2 star, how could it outlive the universe? Dating a star isn't like carbon dating a fossil. Stars don't have birth certificates. Instead, we use stellar evolutionary models, equations that predict how a star's brightness, temperature, and composition change over time. Inputs like mass, luminosity, and metallicity are fed into these models. But like any clock, tiny errors in calibration can lead to wildly wrong times. In 2013, the Hubble Space Telescope took aim at Methuselah. Over a decade, it refined the star's distance, 190 light-years, with unprecedented accuracy. Armed with this data, Penn State astronomers recalculated its age, 14.46 billion years, still older than the universe. But here's the twist. The margin of error was unzero, 8 billion years. The lower bound? 13.66 billion years, just shy of the cosmos' age. Crisis averted? Not quite. Enter the James Webb Space Telescope, JWST. In 2023, it spotted galaxy JADES GAS Z140, a behemoth shining 290 million years after the Big Bang. Its existence defies models. How did such complexity arise so quickly? Some now argue the universe could be 26.7 billion years old, nearly double current estimates. If true, Methuselah's age fits neatly, but most scientists remain skeptical. The universe's age isn't plucked from thin air. The cosmic microwave background, CMB, remnant radiation from the Big Bang, is our most reliable clock. By analyzing its fluctuations, we've pinned the universe's age to 13.8 billion years, a figure corroborated by Hubble's law and the expansion rate. Methuselah's age, then, must be wrong. But where's the error? Recent studies reveal a critical oversight: helium diffusion. As stars age, helium sinks into their cores, altering their luminosity. Earlier models ignored this. When factored in, Methuselah's age drops to 12 billion years. Case closed. Not entirely. The star's apparent age still teases us with cosmic riddles. Science thrives on uncertainty. Methuselah reminds us that stellar models are approximations, not divine truths. Tiny variables, distance measurements, chemical abundance, even the sun's motion, ripple through calculations. Each refinement brings us closer to truth, but absolute certainty remains elusive, and that's beautiful. This star isn't just a cosmic oddity, it's a laboratory. Its low metallicity offers clues about the first supernovae. Its longevity challenges assumptions about stellar life cycles. By studying Methuselah, we're reverse engineering the universe's earliest chapters, one photon at a time. Methuselah humbles us. For decades, we've mapped galaxies, simulated black holes, and probed dark matter, yet a single star can upend our confidence. It whispers, "There's so much more to learn." If Methuselah is population 2, where are its progenitors, the mythical population of 3 stars? JWST may soon spot their ghosts. These pioneers, born in pure hydrogen and helium, likely died in pair instability supernovae, leaving no remnants. Finding them would be the ultimate cosmic connect the dots. Methuselah, now a subgiant, will evolve into a white dwarf, then a black dwarf, a cold, dark relic. But today, it's a vibrant time capsule. To observe it is to gaze into an era when the Milky Way was just coalescing. Grab binoculars. On a clear night, aim for Libra. At magnitude 7, it's invisible to the naked eye, but there it is. HD 140283, a flicker of light older than Earth's continents, older than the sun, older than almost everything. Methuselah's 14 billion years is but 0.1% of its lifespan. If it lived 80 human years, it's a newborn. This scale redefines ancient. We're mayflies in the cosmic dawn, yet we've decoded stars. What more will we achieve in our fleeting moment? Science isn't dogma. If Methuselah forces us to rethink the Big Bang, so be it. Perhaps the universe cycles through expansions and contractions. Perhaps time itself is an illusion. The thrill is in the chase. To every aspiring astronomer, Methuselah is your star. Its paradoxes await your solutions. The tools, JWST, AI, quantum computers, are in your hands. The universe is not a static museum. It's a living puzzle, and you're invited to play. As Carl Sagan said, somewhere, something incredible is waiting to be known. Methuselah is one such marvel, a reminder that the cosmos is stranger, grander, and more mysterious than we dare imagine. So keep looking up, keep questioning, and remember, in a universe of 2 trillion galaxies, the greatest discoveries are still out there.